Welcome back, and I've got another fun experiment for you today. What we're going to do with simple apparatus is we're going to determine the power of a Bunsen burner flame. So I said today we were going to determine the power of a Bunsen flame. And if you remember, what I mean by power is the number of watts this Bunsen burner is. In other words, how many joules per second it gives out. And to do that, we need incredibly simple apparatus. So to do this experiment, I need quite simple apparatus. I've got a beaker here with 200 centimetres cubed of water in it. So knowing the density of water as 1 gram per centimetre cubed, I know that's 200 grams of tap water. And if it's 200 grams, it's 0.2 kilograms of water. I also know something about specific heat capacity. And I know it takes 4,200 joules to raise 1 kilogram of water by 1 degrees C. So what we're going to do is we're going to measure the starting temperature of the water, put a Bunsen flame underneath it and leave it for a while. We'll time how long that is to get a reasonable temperature rise. We're not going to rise the temperature up to 100 degrees C and then boil it, because we're into the realms of latent heat capacity then. So we'll start at room temperature, raise the temperature a reasonable amount, and if we know how much water we've got, how much the temperature has changed by, and how long it took us, we can work out how many joules we fed into the water, and with the time, how many joules per second was fed into the water, and therefore the power of the Bunsen flame. So let's get started. So I appreciate with this experiment there are lots of errors and losses in the system. We're losing heat to the environment, I'm aware of that. We're having to warm up the glass of the beaker, etc. And we may be losing some water vapour as well, which will be taking energy away from the system. But as with most of my experiments, this isn't a detailed and accurate determination. It's more a case of a fun experiment that would show you how you'd go about doing something. Okay, so let's get started. So I've measured the temperature of the water, the starting temperature as 20 degrees C, as expected, room temperature. So let's turn on the Bunsen now and get heating the water. So on goes the gas. And there we go, light the Bunsen. And I want to work out the power of a Bunsen with a roaring flame. So there we go. You might wonder why I've not started the stopwatch, but just letting everything pre-warm a bit, and let's go. So we're going to leave this for a few minutes until we get a reasonable temperature rise, and then we'll work out the temperature from the start to the finish, so the change in temperature and the time it took to do that heating. So we're approaching 4 minutes now. 2, 1, stop. So that's 4 minutes. So I'll remove the Bunsen. I'll just quickly turn it off, and we'll check what temperature the water has gone up to. Shouldn't really stir with the thermometer, I know, but that'll do. So we probably could have left this heating for a little bit longer, but and it's gaining a bit of heat from the gauze, which came from the Bunsen. But the temperature's stabilised at about 68 degrees C. So we've got the mass of the water, we've got the time, which was 3 minutes, we've got the starting temperature and the finishing temperature, and we know the specific heat capacity of water. So what we need to do now is go away and do a little bit of maths to work out what the power is of our Bunsen burner. Okay, so let's quickly just remind ourselves of the data that we got. So we had 0.20 kilograms of water, and our starting temperature, which we measured with the thermometer, was equal to 20 degrees C, so that was room temperature, and we finished at a temperature of 68 degrees C. And I kept confusing whether we ran it for 3 or 4 minutes, but we ran the experiment for 4 minutes. And remember, we must work in seconds, so that's 240 seconds. So to work out the power of our Bunsen burner, we need to know how much energy we fed in total to the water, and then we need to know how much energy per second to get that in watts. So to work out the amount of energy fed in, Q, the amount of energy fed in, is equal to, make that a bit clearer, M, the mass of the water, C, the specific heat capacity of the water, multiplied by the change in temperature, delta theta, or delta T if you prefer. There's lots of different ways of writing that. So the amount of energy, Q, that we fed into the water was the mass in kilograms, 0.20, multiplied by C, the specific heat capacity of water, which is 4,200 joules per kilogram per degree C, multiplied by the temperature change. So from 20 to 68, and that's 48 degrees centigrade. It doesn't matter if you work in Kelvin either. And so the amount of energy that we fed into our water was 40,320 joules of energy over the 4 minutes of heating. So now let's divide that by the time and work out the power of our Bunsen burner. Okay, so we know that power is energy fed in divided by time. So the energy we fed in we call Q here, divided by the time taken in seconds, T. So we fed in 40,320 joules of energy, and we did that in a time of 240 seconds. So if we work that out, we get the power of our Bunsen burner as a rather poor 168 joules fed in per second, or 168 watts. So the power of our Bunsen came out as 168 watts. Now this is really rather low. So you've got to remember that I was sort of demonstrating the experiment here. I wasn't using methods to reduce the errors in the experiment, particularly the fact that we were heating the beaker, we were losing energy to the environment from the Bunsen. It wasn't all going into the beaker, it was going radiating in all directions. But again, with the experiments that I do, the main idea is to show you the concepts, not to do the experiment really accurately. So the main thing to remember is just keep in mind the losses that were involved in this experiment. And if ever you did it in an exam, you'd be asked to state what are the losses. I did actually, and it's quite interesting this, I did actually look up the power of the Bunsen, and I could not find it anywhere at all. I found things that looked like they were powers, but they weren't in fact. So the way you'd have to do it is actually work out how much gas you fed in per second, and then do it from the burning of the methane gas and work out the power there. But my impression is that this figure is well, way lower than it should be. I was expecting a number around 800 watts or something like that. But again, it doesn't matter. It's the concept that matters here, and the fact that we can use physics and we can use the formula that we know to try and work out something. So clearly in this case, if some of the energy was lost to the environment, we didn't record that as a temperature change on the thermometer. So our Bunsen is actually rather more powerful than we calculated today. So I do hope you enjoyed that experiment and demonstration. As ever, I'll be making another video soon, and I look forward to seeing you then.